Assalamu alaikum wa rahmatullah. In this video, we will continue the second lecture of the physiology of the renal system. The very important concept or very important part of the renal physiology is the glomerular filtration rate. The glomerular filtration rate is the total amount of the filtrate that can filtered by all the nephron in both kidney in a given of time, and it is the main function of the kidney. There are different concepts we should understand before understanding and calculating the glomerular filtration rate. Filtration fraction. Filtration fraction is the part of the percentage or the filtrate from the plasma entering the glomerulus, and it is equal to about 20% of the plasma will filter. Renal clearance is the total volume of the renal plasma that substance can completely filtered from it in 1 minute. This concept is important in the calculating of the glomerular filtration rate. You should know we cannot calculate the filtration of the different molecule, like for sodium, like for potassium, or any molecule in the afferent or in the efferent or in the glomerular capillary. So there is should substance that can calculating of this substance give hint for the calculation of the glomerular filtration rate. This substance is called glomerular filtration marker. There are different substances that can be used for calculation of the glomerular filtration marker. There is special criteria for this substance for using it as a marker. It should be easily filtered, completely filtered, not reabsorbed, no secretion. The substance should not harm the body, not toxic. So the most important substance used scientifically is the inulin, but it is external substance used by injection, so not clinically widely used. The most widely used for calculation of the glomerular filtration rate is the creatinine. It is occur or from the metabolism of the muscle, and the production of the creatinine is completely excreted by the kidney, not reabsorbed, so can give a hint for about how much glomerular filtration rate. From this picture we can see this is the afferent arteriole entering the blood to the glomerulus. 20% of this plasma will filtered. This 20% is called filtration fraction, while the other, which is the 80%, will return to the efferent arteriole and the blood vessels. From these 20% filtration fraction, about 19% will reabsorb, which is about 99%. So only 1% of the volume is excreted by the urine, while the other is reabsorbed again. This continuous process, continuous filtration, continuous reabsorption, this allow more precise function of the kidney to reabsorb only the particle or the molecule that is need by the body, while the remainder will be excreted as the waste product. The glomerular filtration rate is affected by different factors. This is important to discuss the factors that affect the filtration. The first is the filtration pressure. In this picture we can see the afferent arteriole coming from the renal artery with having a pressure in this artery. This pressure called hydrostatic pressure. In the afferent arteriole, the hydrostatic pressure is about 100 mm mercury. When entering the glomerulus, entering the capillary, this pressure will reach to the 60 mil mercury. This pressure is the highest pressure in the capillary in the body. This pressure in the hydrostatic pressure will promote the filtration. Other pressure in the capillary is the colloid pressure or osmotic pressure. It depends on the amount of the solute of large particle, mostly protein, in the plasma. This solute or this molecule prevent filtration of the substance from the glomerular capillary, so it is against filtration. Other factor in the filtration pressure is there is also colloid or osmotic pressure of the Bowman capsule. As the Bowman capsule have no protein or only small amount of the protein, so the colloid or osmotic pressure of the Bowman capsule is equal to 0, while the Bowman capsule pressure, hydrostatic pressure of the Bowman capsule is equal 15 to 18. So from the net calculation from this formula, glomerular hydrostatic pressure 60 minus Bowman capsule 18 minus glomerular osmotic pressure 32, so the net filtration pressure equal to 10. The second factor that affect the capillary filtration is the GFR is the capillary filtration coefficient. It depends on the filterability of the substance and also on the surface area of all nephron and the thickness of the capillary filtration barrier on the capsule, on the layer discussed in the previous videos, which is the endothelial layer, basement membrane, and the epithelial layer. Physiological control of the GFR or the renal blood flow is very important. There are different factors for controlling the GFR. First one is the neural factor. As we know from the previous lecture, the kidney is supplied by the sympathetic supply, and there is no parasympathetic supply, and this sympathetic supply it's have control on the GFR by affecting the blood vessels pressure and also affecting the juxtaglomerular apparatus and other parts. Hormonal factor. Different hormone will affect the function of the kidney. From this hormone, renin, which is secreted by the juxtaglomerular apparatus, angiotensin 2, which is also from the renin, angiotensin, aldosterone system discussed later on, and other hormone. Autoregulation of the GFR and renal blood flow is very important concept. We should know that the kidney have intrinsic ability to control its function in different level of the blood pressure. Any change in the blood pressure can affect the glomerular filtration rate normally, but with the autoregulation, this difference is negligible because the autoregulation prevents the difference in the blood pressure to cause change in the glomerular filtration rate. Because if no autoregulation, any increase in the blood pressure that will cause more excretion and more waste, more urine, so this will affect the blood flow in the body. The autoregulation have two factors: tubuloglomerular mechanism and myogenic mechanism, and there is include video discuss these two mechanisms in details. The tubuloglomerular mechanism is the feedback mechanism from the glomerular filtration rate with increasing the glomerular filtration rate and decreasing the solute or filtrate in the and one of these filtrate is the sodium. When the sodium pass to the collecting duct from the proximal collecting convoluted tubule to the loop of Henle till ascending loop of Henle till reaching the juxtaglomerular apparatus, there is a specialized cell called macula densa cell. This macula densa cell will detect the level of the sodium, increasing the level of the sodium, causing the macular cell to secrete different substances that affect the afferent arteriole to cause constriction to decrease the blood vessels, so decreasing the GFR. This is the for tubulo-glomerular mechanism. Myogenic mechanism, also discussed in the included video. We should know that the surface of the muscle cell there is a special channel. With the stretching of this surface area of this layer of the muscle cell, causing opening of this channel. Opening of this channel will causing influx of cation inside the cell that cause depolarization. This depolarization causes constriction of the muscle, so will increase the resistance of the afferent arteriole and affecting the filtration. Important concept to discuss is juxtaglomerular apparatus. Juxtaglomerular apparatus is the part of the kidney when the ascending lobe of Henle changing to the distal convoluted tubule, passing between the afferent and the efferent arteriole. It is consisting of three types of cell. The first one is called macular-dense cell. Macular-dense cell in the wall of the collecting duct, in the wall and the ascending limb of Henle. It's a specialized cell. It is different from other cell of the ascending limb. It is taller, have large cell, and this cell it is chemoreceptor. What we mean by chemoreceptor? It is detect the level of the sodium passing in the filtrate inside the ascending limb. When detect low level of sodium, this cell will secrete different substances that affect the arteriole nearby, so causing constriction. The other type of cell in the juxtaglomerular apparatus is juxtaglomerular cell. This juxtaglomerular cell is the cell of the blood vessels, not cell of the collecting duct. It's also specialized smooth muscle cell. Nearby normal smooth muscle cell of the afferent arteriole. This called also the second name is called the granular cell. Why called as a granular cell? Because contain granule. This is a granule. It's produce, secrete, and store the renin. Renin is very important hormone in controlling the function of the kidney, and we'll discuss the renin, angiotensin, aldosterone system later on. Other part of the cell, it is not so important, and it has not now function. This is the juxtaglomerular apparatus. If in condition of decreased arterial blood pressure in the body, so decrease hydrostatic pressure. This decrease hydrostatic pressure cause decreasing the GFR. So the macular-dense cell, with decreasing the GFR, decrease the filtration, so there is low sodium while entering the collecting duct. Till reaching the macular-dense cell will detect there is decreased sodium, so has two effects. The first effect affecting the afferent arterial resistance will decreasing, so negative feedback on the glomerular filtration rate, so increasing the GFR, and also affect to secrete the renin causing the conversion of the secretion of the angiotensin 2 from the angiotensin 1 and angiotensinogen to the angiotensin 1. Angiotensin 1 converted in the mostly in the lung to the angiotensin 2 by the angiotensin converting enzyme. This will affect the afferent arterial resistance and also causing increasing increasing the GFR. This is picture from the included video. This is the macular-dense cell. This is the juxtaglomerular apparatus, and this is the third part or cell with no function is extraglomerular messenger cell. And also there is different picture. In this picture, this is the collecting duct, and this is the macular-dense cell, and this is the juxtaglomerular cell, and it is nearby. Juxta mean near. Renin, angiotensin, aldosterone system is important system, as from its name, renin, angiotensin, aldosterone system. start from this part. Low sodium, this low sodium in the collecting duct cause the renin secreted from the granular cell. This renin that cause the change of the angiotensin gene from the liver to the angiotensin 1. Angiotensin 1 is ineffective substance, will converting by special enzyme called angiotensin converting enzyme, ACE. This is more present in different part of the body, like in the endothelium of the blood vessels, mostly in the lung. This is angiotensin 2. It is active substance, can act by itself to causing different increasing in the blood pressure, or it has effect by on the aldosterone from the adrenal gland on the kidney, and the aldosterone will affect to increase the GFR and increasing the sodium ion. This is another picture. Also, this is the kidney converting angiotensin gene from the liver to the angiotensin 1. Angiotensin 1 is inactive substance converting by the special enzyme called angiotensin converting enzyme. This is the enzyme converting the angiotensin 1 ila angiotensin 2. Angiotensin 2 is active substance. It's also, it have different action. Affect the sympathetic activity. It's also affect directly on the adrenal gland, on the pituitary, on the blood vessels, and also affect the aldosterone to complete its system. Aldosterone secreted from the adrenal gland, and also will affect the tubular reabsorption of the sodium and complete the cycle. It is important in the blood pressure control, and also important in the water and salt control in the body. In the water balance, as discussed in the previously, by the antidiuretic hormone. Antidiuretic hormone, it is stored and released in the posterior pituitary. There is anterior pituitary and posterior pituitary. In posterior pituitary secreted the antidiuretic hormone, as from its name, antidiuretic, so it is decrease the diuresis, so cause more water in the body. The antidiuretic hormone affect the kidney to decrease diuresis in cases of the decreased water content, decreased blood pressure, and this pituitary hormone, which is antidiuretic hormone, affecting in the distal convoluted tubule on the collecting duct to increase the absorption of the water from the filtrate, and also it affects the sodium concentration, more water entering the blood, re-entering the blood vessels, so causing decreasing the sodium, because low sodium, more fluid, so causing decreased concentration of the sodium. Acid-base balance. It's also important function of the kidney. There is two concepts, acidosis and alkalosis. Acidosis is the increase of the hydrogen ion, and it is decrease the pH, while alkalosis is the opposite. In case of the acidosis, the body can control this acidosis by 3 steps. The first step, it is by neutralize of this acid by different buffer system in the body. It is quick step, but it is weak. Try to neutralize the acid. The second step, if the buffering system not control all the acidity of the blood, so the next step done by the lung, by increase or decrease the depth of the breathing, so can excrete with the breathing, with the oxygen, more with the air, more hydrogen or more bicarbonate. The third step, which is important and discussed in the renal system, is the effect of or the function of the kidney in the acid-base balance. In the function of the kidney, or the role of the kidney, or the step of the kidney in the acid-base balance, it is late, coming late, but it is strong. In case of the acidosis, with more hydrogen and the ion in the blood, the kidney cause more hydrogen excretion in the urine, while in the opposite, in case of the alkalosis, so the kidney will cause the hydrogen ion more reabsorbed and bicarbonate more excretion, so controlling the acid base in the body. Thank you for your listening.